This is a laser security system. This setup can be installed around your home or in any area where you want to add an extra layer of security. If someone crosses the laser's path, our system detects it, triggering a visual and audio alert. Let's take a look at the components we'll need for this project. First, we need an Arduino UNO board. Next, we have a laser emitter to create our detection line, an LDR sensor or light-dependent resistor to detect the laser, 4 LED to indicate an alert visually, a buzzer to make sure we hear the alert too, 5 220 ohm resistors to protect our LED and components, 1 small and 1 mini breadboard, some male-to-male jumper wires, a USB cable, a battery holder with a DC power jack and switch, 2 lithium-ion batteries. Now, let's go through the connections. First of all, take the small breadboard and Arduino. Start by inserting LED on this breadboard. Now connect the negative, that is shorter leg of each LED, to the ground rail of the breadboard using 220 ohm resistors. Now take male-to-male jumper wires. Connect the positive leg, that is the longer leg of the first LED, to digital pin 4 on the Arduino. The second LED connects to pin 5. The third LED goes to pin 6. And the fourth LED goes to pin 7. Now insert the buzzer on the breadboard. Connect the positive terminal of the buzzer to digital pin 12 on the Arduino. The other end of the buzzer goes to the ground rail, so it shares the same ground as the LED. Now, let's set up the LDR sensor. Connect one leg of the LDR to the power rail on the breadboard, and connect the other leg of the LDR to analog pin A0. Take the resistor and insert it in between the LDR leg connected to a 0 and the ground rail. This resistor acts as a voltage divider to help read the light level correctly. The last step is positioning the laser emitter so it shines directly onto the LDR. So insert it in the mini breadboard. Connect its signal pin to the power rail of the small breadboard. Connect its negative pin to the ground rail of the small breadboard. Using jumper wire, connect the GND pin on the Arduino to the ground rail on the breadboard. Also connect the 5V pin on the Arduino to the power rail on the breadboard. Make sure to double-check your connections with the circuit diagram. Now our circuit is ready and we need to add the code. Download the code file given in the description below. Open the code file if you've already downloaded the Arduino IDE, otherwise download the Arduino IDE first. First, we define the pins for each component. We are using pins 4, 5, 6, and 7 for our LED, pin 12 for the buzzer, and analog pin A0 for the LDR sensor. This helps us keep track of what each pin is connected to throughout the code. Next, we define a threshold value for the LDR sensor. This threshold is set to 500, which means if the LDR value drops below this number, it will trigger the alert. You may need to adjust this threshold based on the brightness of your laser and the ambient lighting in the room. In the setup function, we define the modes for each pin. We set the LED and the buzzer pins as outputs because they will send signals to the components. The LDR pin is set as an input, as it will be receiving a light level reading. We also begin serial communication at a 9600 baud rate. This lets us use the serial monitor for debugging, which will help us see what's happening with our sensor values in real time. Finally, we send an initial message to the serial monitor so we know the system has started. Now we move into the loop function, which will run continuously. First, we read the value of the LDR sensor using analog read LDR pin and store this reading in the variable LDR value. This gives us a number that represents the current light level hitting the LDR. We then print the LDR value and the threshold to the serial monitor. This lets us monitor the LDR values in real time, making it easier to troubleshoot and adjust the threshold if necessary. In this section, we check if the LDR value is less than the threshold. If it is, that means something is blocking the laser and we need to activate the alert. When this condition is true, we turn on the buzzer by setting digital write buzzer high. Then, we activate a lighting sequence for the LED. Each LED lights up one by one with a delay of 200 milliseconds between each, giving a sequential lighting effect. After all LEDs are on, we turn them off one by one with another 200 millisecond delay, creating a loop effect that enhances the alert. If there's no interruption and the LDR value is above the threshold, the else block runs. Here, we turn everything off, the buzzer and all LED. We also print a message to the serial monitor saying, "System normal, no intrusion," to confirm that everything is working fine. Finally, we add a 100 millisecond delay at the end of the loop to prevent the microcontroller from being overloaded by too many readings. And that's it. Now upload your code to the Arduino. Connect the Arduino UNO to your computer using the USB cable. Then select Port and Board in the same menu and select Arduino UNO. Now upload the code by clicking the Upload button. Now install the circuit outside some house-type structure made up of cardboard. Make sure that the surface of the LDR and laser emitter face each other. And plug the DC power jack of the battery holder into the Arduino's barrel jack to power the Arduino directly from the batteries. Switch it on. And that's how our project works. This laser security system uses an LDR sensor and laser emitter to detect intrusions. When the laser path is interrupted, it triggers a buzzer and a sequence of LED to alert us of any movement. I hope you found this tutorial helpful. Thanks for watching our tutorial.